Hello and welcome to this tutorial on modular safety. My name is Volker Marks from Kendrion, and I will explain to you here what modular safety means and then show you how to create your first safety application using a small CODESYS project. Let's go. If you wanted to use our safety PLC in the past, you needed a safety package from us. This was always linked to a specific CODESYS version, for example CODESYS 3.5.16 patch 4. This meant that it was not possible to use a newer version of CODESYS than the safety package. Not nice, but unavoidable at the time. Since CODESYS 3.5.19 patch 6, this has fortunately changed. From this version onwards, safety is independent of the CODESYS version and can be installed in any version via the CODESYS installer. This is exactly what the term modular safety describes. As always, there are a few stumbling blocks on the way to your first safety project, but I will of course point these out to you in this tutorial and show you how to avoid them. Before we move on to the project, you first need the device description of the safety modules. You can find these in our product finder, link under the videos in the respective download area. There are currently three variants of our safety PLCs. The standard safety PLC, the safety PLC EXT with an integrated extender, and the safety PLC EC with an integrated bus coupler. The standard and EXT variants are used with one of our head controllers, and the EC variant with any CODESYS controller. An EtherCAT master is also sufficient for special cases. For our safety PLCs, you will find a CODESYS safety package in the download area. In addition to the device description of all safety modules, this contains all the required safety libraries. Please download this package. Before we start CODESYS, we install the safety extension and the downloaded safety package for the safety PLC. This can be done with the CODESYS installer. So we start the CODESYS installer and then select the appropriate CODESYS version. If you have several CODESYS versions installed, select the one you want to use for safety. In this tutorial we will use CODESYS 3.5.20 patch 3. First we install the CODESYS safety extension. Click on Change. Select Browse to search for the safety extension. Enter safety in the search field. The CODESYS safety extension appears. Select the latest version. At the time this tutorial was created, this was version 4.2.0.0. Start the installation and wait until the process is complete. Then install the downloaded CODESYS safety package. Click on Install File and install the package. We are now ready to create our first safety project. We are using our safety PLC EC as well as our safety I/O, an FSoE drive and a safe FSoE fieldbox from SMERSOL. We start CODESYS and first check that the safety installation is correct. Help. Show safety version information, and the installed safety version appears. We confirm the information and can now install our missing device descriptions. For all our safety components, these have already been installed with the package, but if you want to add a drive, you can do this via Tools, Device Repository, Installation. Now we come to our project, File, New Project. The empty safety project template is available here, which contains an empty project with pre-configured user groups for safety. However, to keep things simple, we choose Standard Project and CODESYS Control. WinV3 as the device. Now this soft PLC must be started, and the easiest way to find it is to enter CODESYS Win in the Windows search dialog. Please pay attention to the correct version. We use 3.520. The Win PLC is started and we establish a connection. Search for the Win PLC in the Scan Network dialog of the device. Enter username and password. These were defined during the first installation of the Win PLC. An important note: please remember your username and password, otherwise you will not be able to log in later. Now we add an EtherCAT master. Right-click on Device, Add Device. Select the EtherCAT master under EtherCAT. Add Device. Close. The EtherCAT interface must now be configured. Double-click on the EtherCAT master. General. Select. Our safety PLC is connected here via a USB LAN adapter. Now we connect our slaves to the EtherCAT master. A small problem here too. Although CODESYS offers a dialog for scanning the EtherCAT bus, there were still problems with it when this tutorial was created. This problem should be fixed in version 21. Since the scan does not work reliably, we add the devices manually. Right-click on EtherCAT master. Add device. Enter safety in the search dialog. Select device and add device. And we add the Kendrion Safety PLC EC. Then add the safety I/O with 16 inputs and 4 outputs. As this is connected directly to the safety PLC, right-click on the safety PLC and attach the Kendrion Safety I/O with 16 inputs and 4 outputs. Now we add the FSoE drive. As this hangs directly under the EtherCAT, right-click on EtherCAT master. Select FSoE drive. Add device. Close. Likewise the Schmersal field box. Now a little cosmetic surgery. By attaching the EtherCAT master, we have 2 tasks, of which we only need the EtherCAT task. So move the PLC part G block to this task and delete the main task. Okay, what exactly do we see in the device tree? The use of safety means that there are now 2 applications. We call them gray and yellow. Gray refers to the non-safe areas, and yellow to the safe area. Under the EtherCAT master, we see all EtherCAT slaves. The safety PLC is also part of this, although it is also the FSoE master. Below the safety PLC, we find the safety application and the logical I/Os of the FSoE slaves. The slaves can be configured here, and the yellow process data can also be seen there. For example, all yellow inputs and outputs of the safety I/O or the variables for STO command and STO status on our drive. So far, so good. Now let's write our first small safety program. This is of course created under the safety application. Right-click, add object, and we select a basic POU. The language in the safety editor is function block diagram, and only integer data types are permitted here. But what if you need complex arithmetic functions that also need to be secure? Good news, Kendrion has a solution for this. Complex calculations, for example safe kinematics, can be realized in separate function blocks. These are written in C and called cyclically in the safety task. Please contact us for further information. We only use standard blocks from the CODESYS library here, and the most important one is the one for monitoring communication with an FSoE slave. Switch to the POU. Insert box, and then we find the FSoE master module here and insert it. The instance is the name of the respective yellow process data. Unfortunately, the search via the 3 dots does not yet work here, so right-click on the respective data. Properties. Select the name and then copy and paste. As the function block switches to the error state when the EtherCAT master is stopped, and this happens frequently during commissioning, we set the auto-reset input to true. For the remaining slaves, we copy the block and only change the instance name. Now we come to a really very popular error. This is the setting of the FSoE address. Each FSO slave has a unique address, which is set on the Kendrion Safety I/O via a dip switch, or as with the FSO drive, via the corresponding configuration software. We have set the drive to address 1, the Safety I/O to address 2, and the Schmersal field box to address 3. In CODESYS, the settings can be found in the device editor of the logical I/Os, and then under Safe Configuration. Please set the FSoE address and the connection ID to the identical value. First the Safety I/O, address 2, then the Safe field box, address 3, and then the FSoE drive with address 1. So far okay. But here is the next possible error. As the safety functions can be configured in most drives, a safe checksum results depending on the configuration. This value must be entered under Drive Safe Parameters CRC. We copy this value from the corresponding configuration software and are now ready for a first test. we first log into the grey application. Click on the green icon next to the list box and start the program using the small arrow to the right of it. Then we select the yellow application from the list box and log in here too. First, the instance identification must be entered. This is the number printed on the front of the safety PLC. OK, and then yes. I have created a boot application. We leave the password empty and confirm the dialog with yes. This creates a secure boot application, and we can now start it by clicking on the small arrow. If we now switch to the yellow POU, we see a diag code on each module, which shows us the status of communication with the slave. For better diagnostics, we switch to the hex display mode. Debug, display mode, hex. Hex 8068 means that valid data is both read and sent. If you receive an error here, you will find a detailed description in the CODESYS Safety manual. Now, we want to set the STL output for our drive and use a safe input of the field box for this. First log out of the yellow world. Answer all windows with yes or OK, then insert network. Insert assignment and we select the first input of the field box, here port 0. We now switch this input to STO command via assignment. SS1, SLS and so on can be set in a similar way, but safe positions or speeds can also be processed. Now let's move on to communication with the grey world. An example. The diagnostic code of the FSoE master module for the drive should be displayed in the grey world. There are exchange variables that communicate in both directions. These are added under the logical IOs. Right-click, Logical IOs, Add Object, Logical Device. And under Logical Exchange Device, we find the corresponding variables. The diagnostic code is of type Word, so we select Logical Exchange Object Word Type Output. We give this variable the name wdiag_drive. We now enter this variable in the block. The variables can be found under the global variables. All exchange variables must now be made known in the grey world. To do this, we first log out of the grey world. Right-click Application, Add Object, Logical Exchange GVL, and Add. An empty window appears, and no variable is visible here yet. All variables that have not yet been included can be found in the list box below the dialog. However, only one variable can be transferred at a time. At this point, I would like to point out another common mistake. To see the exchange variables in online mode, they must also be called up. This is often forgotten, so we add this variable to the PLC PRG block. We use the extremely helpful F2 search key for this. Under Application, we now find our variable. Please do not forget the semicolon. We are now ready for the final test. We log into the grey application and start the program. Then in the yellow application. And start this too. In the PLC PRG block, we now see the diagnostic code hex 8068. Then we test the control of the STO command, switch to the yellow world and set the input of the field box. The STO output goes to true. We can also see the STO input in the configuration tool of the drive. After setting, the access is now ready to drive. We have now reached the end of the tutorial, and if you have any further questions about safety, want to know more about our safety libraries, or need support with commissioning, please contact us. We look forward to exchanging ideas with you. And that is also safe.